I'm going to show you 3 examples today, and I'm going to show you some examples more than once, depending on how you can solve them. What you will find is when you get into multi-step equations, 2-step, 3-step, 4-step, etc., there are multiple ways to solve these problems. Sometimes it's just preference. Sometimes there is a better choice, a better path to follow. So I'm going to try to show you some of those today. However, in doing, I want to point out some things that are commonly done wrong in solving 2-step equations. There are some very simple things that people do wrong consistently, even this year that I've seen so far. So I want to address those things this morning. So make sure you're paying attention to both these things, because I will show you things that are good and I'll show you things not to do. And I want them to be confused. Otherwise, we will be in a world of hurt, my friends. Okay? So let's start with a simple 2-step equation. 2x plus 3 equals 7. There we go. This is a 2-step problem. There's ways you can know that up front. First of all, if you see that there are multiple operations taking place around the variable, you know you're in a multi-step problem. Let me show you what I mean by this. When I look at this, okay, and zooming in here, when I see this, I see, right here, I see multiplication taking place. Okay, so I know multiplication is taking place. And then when I'm looking right next to it, I see this sign, and that very quickly, and as you see that sign, it's the addition sign, I see that addition is also taking place. And so what I know automatically is that I'm going to have to do the opposite of both of those in order to solve this. But that's not the hard part. The hard part is figuring order divide. It matters. Okay? However, and this is the big caution, and this is the big red flag, you're not going to use PEMDAS to help this out. You're going to use practice and experience and your teacher's guidance to help you figure this out. Because PEMDAS will lead you down the wrong path. Okay? It will not point you in the right direction. So when you are focused on a problem like this, my guidance to you is start as far away from the variable and work inward. So in this particular situation, you see that there is a number, 2, that's really close to the variable x. The whole point of solving an equation is to isolate that variable. You want to get it by itself. You want it to be all by its lonesome on one side of the equation. The preferred side would be the left-hand side because it's already there. But if I had to move it to the right, it's possible. But as long as it's by itself, we're fine. So to get it by itself, I have to do 2 things. I'm going to have to do subtraction. It's the opposite of addition. And I'm going to have to do division, which is the opposite of multiplication. Okay? I do the opposite operation, to solve the equation. So this equation is going to be solved using addition and division. The question is, which one do I start with? Yes. Yeah, I'm going to start by removing the 3, and I should say moving the 3 to the other side using subtraction, because it's the furthest away from the x. Okay? The closer the variable, or the closer the number is to the variable, the last, or that's the number you're going to want to deal with last. So yeah, I want to subtract 3 first. What I do to one side, Liam, I do to the, yes, very good. Okay, so we haven't forgotten everything. That's good. Okay? What I do to one side, I must do to the other. It's the golden rule of mathematics. And then I can go through, when I'm done with that, and I can divide by 2. And this will isolate the variable, and it will solve it in the proper order, which is important. So let's do it. So I'm going to start by subtracting 3 from both sides. I'm going to rewrite it so that I can keep these notes right here. If you want to do the same, that's fine. 2x plus 3 equals 7. I am going to start by subtracting 3 from both sides. So subtract 3, subtract 3. Okay. I'm going to actually treat it like 2 individual problems. I'm going to solve this first, write what's left, then solve it again. So I'm going to work this. Working it. Yeah, minus 3. Out. I'm going to carry down 2x. 7 minus 3 is, Mr. Lehman. Oh, thank you, sir. Yes, it is. Okay, and now I am dealing with a 1-step equation. I've gotten rid of a step. I've shrunk the problem. I now can work with it, and I'm still going to do what I originally planned on doing. I have done subtraction, the opposite of addition. And now I can divide, which is the opposite of multiplication. I'm going to divide by 2. The 2's cancel. Really what they do is they become 1. 2 over 2 is 1. But we don't really have to write 1, so we just say it cancels. It's not really going away. It's just changing form and kind of becoming hidden. So the 2 over 2 is really 1. 1's there. It's not 0. That would totally eliminate everything. It's a 1, but we don't have to write it, so we say it cancels. It's kind of a tricky term. So the 2's go away. They cancel. Okay. And we're left with x equals 4 divided by 2, which is what? Really? I'm going to go to that right now. Okay, so he can come back in 5 years and listen to this recording and realize that was a doofus move. All right. 4 divided by 2 is? Thank you. Oh, okay. Redemption. X equals 2. Now, that's all fine and dandy, ladies and gentlemen, but that doesn't actually tell me whether I did it correctly. I could do anything. I could have done smiley faces, thrown some stick figures in there, maybe like, a buffalo, whatever. Needless to say, it may or may not be correct. So, a good rule of thumb on a test is to take your answer, go back, plug it in, and see if it works. And if you do this a couple of times right at the onset of the test, you're doing it right, the odds are you've got the math down. And so you can quickly work through the rest. But if you find that you're doing it wrong, you can fix your mistakes first and then work from there. So let's go ahead and take this back up and plug in. So 2x, which is really 2 times 2, if x equals 2, plus 3, should in theory equal 7. If it doesn't, we've done something wrong, okay? So 2 times 2 is 4, plus 3 equals 7. 7 equals 7. That is a true statement. You're going to see it. Ah, there it is. Look at that. And check mark. It's done. It's correct. So yes, I did the mathematics correct. Had I done division first, in theory, I could have solved it. I'm not saying it's not the proper approach. But I will warn and caution you in this. If you had done division first, you're going to look at your problem and be like, oh, what just happened? Okay, and the odds are you're going to make a mistake. It's possible to do division first. Don't do it, because it will create all kinds of fractions. There will be distributive property work going on there. There will have to be reciprocals. And trust me when I say distributive property, fractions, and reciprocals, those 3 things all together probably are going to make cringe. Okay, this is simple. Subtract, divide, done. Let's look at another one. This time, though, we're going to look at something that's going to use different operations. Okay, so here we go. Let's do x over 7 plus 4 equals 10. All right. Now, I'm going to need to kind of figure out ahead of time here which 2 operations are happening so that I know what to do to solve it. Okay, Kennedy. Okay, I'm going to need to use subtraction and multiplication because I see division, which is happening right here. And I see addition, which is happening right there. Okay, so I'm going to do multiplication, correct, and subtract. Which order am I going to do them in? What would be the most effective, most efficient way to solve this? Yeah. I'm going to subtract 4 first, then I'll multiply what's left by 7. Excellent. Very good. All right, so let's go ahead and do that. I'm going to subtract 4. Solve like a single problem. 4's go away. Carry down what's left. 10 minus 4 is, idea. Oh man, now we doing good. Okay, 10 minus 4 is 6. I have a new problem. I've gone from a 2-step to a 1-step. So now I go ahead and I multiply by 7. Just to get in the habit of it, don't just put multiply by 7 out front. Do 7 over 1. That is the proper way to write this because you're dealing with x over 7, which is a fraction. Okay? And when you set it up as 7 over 1, you see why it cancels. You have a 7 in the top, you have a 7 in the bottom, and you have cross simplification happening there. Okay? But even so, okay, and I need to make this over 1. This is really the way it unfolds mathematically. However, I want to point out something in writing like this, and this is what I mean. When you have fractions and you multiply them, you multiply through the top and you multiply through the bottom. Okay, so 7 times x is really 7x. 1 times 7 is 7 equals 6 times 7, which is 42. 7 over 7. What is that really? It's 1. There's really a 1 there. It's not just going away. It's not disappearing. Relax, yo. Okay? It's not going away. It's there. We just don't write it. That's really important for you to understand because the next problem is real tricky. Okay? And the whole key to the next problem, which I'm going to show you, is based on this idea that if there's a 1 out front, we don't necessarily write it, but it's there. So the 7s become 1. We say they cancel out. And boom, you're left with x. So x does equal 42. Nice job, Casey. Okay. Now, the next one, which is the tricky one. That's not what I wanted to do. 2/3 x plus 4 equals 16. All right. You can't just do the opposite operation on this one. Okay? You got to start thinking through some of how to solve this. So let's walk through, first of all, what is happening and see if we can figure this out. There is addition, okay, happening with the 4, and there's multiplication happening with the 2/3 and the x. Okay, it's happening here, and it's happening here. Okay, so we have multiplication and we have addition. So the logical options would be division and subtraction. Okay, but because of the fraction there, that complicates things just a wee little bit. Okay, so we are going to get rid of the 4 first. That's obvious, that's easy, but then we're going to have to deal with the fraction, and that's a little trickier. All right, so I'm going to go ahead and get rid of the 4 here. I'm going to move the 4 by subtracting it from both sides. Carry down what's left. So I have 2/3 x equals 12. Okay. Could divide by 2/3. That's not a whole lot of fun. It's dividing a fraction. Are weird when you start to divide. What could I do to turn that 2/3 into 1? Really, that's what we're doing, right? To cancel it out, we need to turn it into 1. What do you multiply any fraction by to turn it into 1? Oh, beautiful. The word of reciprocal. If you multiply any fraction by its reciprocal, it turns into 1. And if there's a 1 there, it can go away, and it's like solving it. It's like canceling it out. So, what is the reciprocal of 2/3, Mr. Landon Smith? 3 seconds. 3 halves. Yes. So let's do it. Okay. Right to Mr. Blair. Okay. So if I multiply by 3 halves, or 3 seconds, okay, not really 3 seconds because that's a time, sounds like time, but 3 halves, okay, then I have to do the same thing to the other side. That's the whole point of the golden rule. So I have to multiply the other side by 3 halves. Now I'm working with fractions, so when it pops up, boom, I'm going to put 12 over 1, just to make it so that my brain can go, okay, I see what's happening here. All right. I'm going to copy this to a new slide so that I can work with it with more space. Okay? Now, what happens to the 3 halves times 2/3? It becomes what over what? It does become 1, but for the 1, it becomes what over what? 6 over 6. Okay, so really we get 6 over 6 times x equals 12 times 3. 36, and that'll all be over what? 2. Okay, 6 over 6 is really 1. So in theory, this is 1 times x equals, what's 36 divided by 2? 18. And so really this is just x equals 18. The reciprocal is really doing two things at once. It's multiplying and dividing. It's actually performing 2 steps for us, but it's doing it in 1 step. There's a way around the reciprocal, but requires turning this problem into a 3-step problem. That's not as easy or as fun. The reciprocal really makes our life a lot easier. By multiplying by the reciprocal, it removes that fraction from the left-hand side, moves it to the right-hand side, and this really isn't very hard, okay? Yeah. I think I know what you're saying. And technically, if you had divided by the fraction, you would have then flipped it and multiplied. So yes, in theory, you would have gotten to the same answer. Okay, but I wanted to show it to you this way. Okay, and you did get to the right answer, which is no surprise to me. Okay, so here we go. So that's how that works. All right, let's look at it if it was a 3-step problem, just so you can see how it would have looked. Casey's method is actually quite a bit faster. It's basically the same as this, just a little different. But if you have any questions, you can always hit him up, and he'll help you out. Okay, so let's go ahead and look at this problem again, but without using the reciprocal. 2/3 x plus 4 equals, what was the original problem? Equals 16. Okay, I'm going to start the same way as I did before by subtracting 4 from both sides. And I'm going to end up with 2/3 x equals 12 again. This time, however, instead of multiplying by the reciprocal, I can really think of it like this. Think of it as x over 1. Okay, so instead of x, think of it as multiplying by x over 1. Really, if you think about it like that, you have 2x over 3 equals 12. That's just a different way of looking at a 2-step problem. What would I do to solve this problem looking at it this way? What could I do to both sides first? Yeah, times 3 to both sides. Okay, the 3's cancel out. I'm left with 2x equals 36, and then what do I do? Divide by 2. Sure. Okay, that's good. That's good. Yep. Okay. That's fantastic, my friend. So you don't have to use the reciprocal, but really what you're doing is the same thing. Divide both sides by 2 here. Cancel the 2's. Not really canceling. It just becomes 1. And it becomes x equals 18. All right. Any questions about this? I'm going to tell you this is what I would consider probably one of the 10 most important concepts you're going to learn here. Solving equations. This being able to manipulate numbers, look at them in terms of like over 1 or reciprocals, these are important ideas.